The James Webb Space Telescope, JWST, has taken the world by storm with its stunning new images, one of which suggests something truly extraordinary about our universe. The latest data challenges long-standing assumptions and hints that there may be something deeply wrong with how we have understood the cosmos. These images reveal galaxies that seem impossibly old, well-formed, and structured in ways that contradict the current models of the universe's evolution. This is no small matter. The implications are profound, as it seems to suggest that either space itself is behaving in ways that defy logic, or our understanding of space, time, and the cosmos may be seriously flawed. The excitement in the scientific community has given way to a growing sense of unease. The discoveries coming from JWST are raising more questions than answers, and it's clear that this is just the beginning of a larger scientific reckoning. To make matters even more intriguing, there seems to be a conflict among scientists themselves. As these findings emerge, the scientific community is split. Some are suggesting that the universe is exhibiting signs of intelligence, with its strange anomalies behaving in a way that suggests purposeful action. Others are holding on to the belief that these findings are simply errors in our interpretation or measurements. But as more discoveries pour in, it becomes clear that something is indeed wrong with the way we have understood the universe up until now. And while scientists debate the meaning of these findings, the rest of the world watches, eager to understand what it all means. Is this the beginning of a new era in science, or are we on the brink of uncovering something even bigger, more complex, and far more unsettling? It's important to understand that the discoveries we are seeing now are not just anomalies, they are discoveries that defy the very foundation of modern cosmology. For decades, the prevailing theory about the universe has been that it is mostly homogeneous, that it looks essentially the same no matter where you are or where you look. This idea, known as the cosmological principle, has been a cornerstone of our understanding of the universe. The principle holds that the large-scale structure of the universe is uniform, meaning that galaxies, stars, and cosmic phenomena should be evenly distributed in all directions. This assumption has shaped everything from the Big Bang Theory to the calculations of how the universe has evolved over time. But the latest observations from JWST suggest that things are not so simple. One of the most intriguing and puzzling discoveries is related to the distribution of quasars, which are incredibly bright and energetic cores of galaxies, powered by supermassive black holes. JWST has observed that these quasars are not evenly distributed across the sky. In fact, scientists have discovered that one side of the sky contains roughly 0.5% more quasars than the other. At first glance, this may seem like a trivial difference, but in the world of cosmology, such variations are not taken lightly. If the universe were truly homogeneous, there should be no discernible difference in the number of quasars from one side of the sky to the other. But this discovery, along with other similar findings, suggests that the distribution of matter in the universe is not as uniform as previously thought. This raises a critical question: if the universe is supposed to be homogeneous, why are there such inconsistencies in the distribution of quasars? Another key discovery that challenges our understanding of the universe is the observation of two enormous cosmic structures, the Big Ring and the Giant Arc. These are vast, sprawling collections of galaxies and galaxy clusters that extend across unimaginable distances. The sheer size of these structures is staggering, with some of them exceeding the scale at which the universe was supposed to be homogeneous and isotropic. In simple terms, these structures are so large that they stretch the limits of our ability to measure them accurately. They appear to be outliers, something beyond the normal framework of the universe's structure. They challenge the very notion of a smooth, homogeneous universe. The fact that these megastructures exist suggests that there may be massive irregularities in the way matter is distributed across the universe. They appear to be mountains in the cosmic landscape, but how did they form? And how do they fit into the overall picture of the universe's evolution? These are just a few examples of the many new discoveries being made by the James Webb Space Telescope. What's becoming clear is that the more we look into the cosmos, the more we realize that our previous understanding of the universe is deeply flawed. There are inconsistencies, anomalies, and puzzles that we have no answers for. The universe seems to be revealing its secrets in a way that no one expected. These discoveries are causing scientists to rethink everything they thought they knew. The idea of a homogeneous, isotropic universe is quickly being called into question, and the universe is starting to look more like a dynamic, ever-changing entity than a static, unchanging expanse. Before we delve deeper into these recent discoveries, it's important to understand the origins of the idea of a homogeneous universe. The notion dates back to the early 20th century when Albert Einstein introduced the concept of the cosmological constant as part of his general theory of relativity. Initially, Einstein believed the universe was static, neither expanding nor contracting. But as new observations revealed that the universe was actually expanding, the static model was abandoned. In the years that followed, physicist Alexander Friedmann showed that Einstein's field equations could also describe a universe that was either expanding or contracting, leading to the development of the Big Bang theory. This theory suggested that the universe began from a singular point in space-time and has been expanding ever since. As the universe continued to grow, it was assumed that the matter within it would be evenly distributed, leading to the idea of a homogeneous and isotropic cosmos. This understanding of the universe's large-scale structure was further reinforced by the discovery of cosmic microwave background radiation, CMB. The CMB is the afterglow of the Big Bang, a faint, uniform radiation that permeates the entire universe. It was first detected in the 1960s and has since become one of the strongest pieces of evidence supporting the Big Bang theory. The uniformity of the CMB suggested that, in its early stages, the universe was evenly distributed, with matter and energy spread out in a relatively uniform manner. This led scientists to believe that, on large scales, the universe would continue to be homogeneous and isotropic. However, as the data from JWST and other observatories continue to flood in, it's becoming clear that the universe may not be as uniform as we once thought. One of the most surprising aspects of the new discoveries is the realization that the universe might not be expanding in the empty space we once thought. For decades, scientists believed that the Big Bang marked the creation of both space and time, and that the universe was expanding into nothingness. But what if the universe is not expanding into a void, but into something else entirely? What if the expanding universe is encountering other structures, dimensions, or even other universes as it grows? This is where the idea of the multiverse comes into play. Quantum physics has already suggested that the universe we know may be just one of many in a vast, interconnected multiverse. According to this theory, the Big Bang could have been just one of many such events, each giving birth to its own universe. If this is the case, then the universe we live in might not be expanding into an empty space, but into a vast, multidimensional cosmos that we cannot yet fully comprehend. Some researchers have proposed that the inconsistencies and anomalies we're seeing in the universe may be the result of interactions between different universes or dimensions. If the universe is expanding into a larger, multidimensional space, then it might encounter resistance or obstacles that disrupt the homogeneity we once thought was a fundamental property of the cosmos. Just as Earth began as a homogeneous ball of gas and dust and gradually developed into a more heterogeneous world, the universe may also have evolved from a smooth, uniform state into something much more complex and varied. This idea, while still speculative, is gaining traction among some physicists who believe that the universe's expansion could be influenced by forces from outside of our own space-time. To understand this concept more fully, it's helpful to think about our own planet. Earth began as a homogeneous mass of gas and dust, much like the early universe. Over time, however, it developed into a heterogeneous world, with oceans, continents, mountains, and valleys. The distribution of matter on Earth is not uniform. There are areas of high concentration, like continents and mountain ranges, and areas of low concentration, like oceans and deserts. Similarly, the solar system itself is a mix of homogeneous and heterogeneous elements. The gas giants, like Jupiter and Saturn, are relatively uniform in their composition, while the rocky planets, like Earth and Mars, exhibit a wide range of diverse features. In the same way, the universe may have evolved from a homogeneous state into one that is far more complex and varied, with regions of high concentration, like galaxy clusters and superstructures, and regions of low concentration, like vast cosmic voids. The implications of these ideas are enormous. If the universe is not homogeneous, if it is expanding into a multidimensional space full of other universes and structures, then everything we thought we knew about space, time, and cosmology may need to be rethought. The discovery of giant cosmic structures like the Big Ring and the Giant Arc, as well as the uneven distribution of quasars, suggests that the universe is far more dynamic and complex than we ever imagined. The homogeneity that we once believed was a fundamental property of the cosmos may be nothing more than an illusion, a simplification that has helped us understand the universe, but not necessarily an accurate reflection of its true nature. As the James Webb Space Telescope continues to gather data and send back images of the cosmos, it is becoming increasingly clear that the universe is not the static, predictable entity that we once thought it was. The discoveries we're seeing now are just the tip of the iceberg, and there are likely many more surprises to come. What's certain is that the universe is far more complex, dynamic, and mysterious than we ever imagined. And as scientists continue to unravel its secrets, we may soon find ourselves on the brink of a new understanding of space and time that could change everything we know about the cosmos. The future of cosmology is incredibly exciting, and we're just beginning to scratch the surface of the mysteries that lie ahead.